Hello students and welcome to Shri classes. Today we'll solve some numericals based on surface areas and volumes of cylinder. That is exercise number 13.2, and one more exercise is there that is related to volumes we'll look at. This is lecture number 3, and in my last class we have already studied the formula for the curved surface area, total surface area and the volume of a right circular cylinder. So let us solve the exercises from exercise 13.2 that is related to surface areas and volumes. So let's see now what is the first sum. Here also I am going to solve the odd number numericals, and even number numericals must be solved by yourself, and take that as an assignment and submit it. So let's have a look at the first question of exercise 13.2. Come. Exercise 13.2. Assume pi equals 22/7 unless stated otherwise. First question, the curved surface area of a right circular cylinder of height 14 cm is 88 square centimeter. Find the diameter of the base of the cylinder. So what is given in this one? It is a right circular cylinder, height is given and curved surface area is given. So find the diameter of the base of the cylinder. Simple. Let us solve this on the board. Question number 1. Cylinder. Diameter is the question. Height is given 14 centimeter and curved surface area is given as 88 square centimeter. We know the formula. Curved surface area is equal to 2 pi RH equals 88. 2 into 22/7 into R, which we have to find out, into 14 centimeter is the height, which is equal to 88 given already. So 7 ones are 7 twos are 2 into 22 into 2, 2 twos are 4, 4 twos are 8, 4 twos are 8. So 88 times R equals 88, R equals 88 by 8, 1 centimeter, and hence the diameter is equal to 2 times R, that is 2 centimeter. You can pause the video and note it down. Now, before I go to the third question, one more conceptual part is to be discussed, and that is the right circular hollow cylinder, which is also called a pipe section. This is how it looks like. A pipe, there is a thickness for this pipe and there are two radii. It is a hollow cylinder, okay? It is a right circular hollow cylinder. Why it is a right circular hollow cylinder? Right circular because height and radii are perpendicular to each other, therefore right circular hollow cylinder, okay? Now, there are two radii. Inner radius, that is small, this small r is the radius of the inner cylinder and capital R is the radius of the outer cylinder. Is it clear for you? And h is the height. So this top portion which has been hashed over here, that is a circular ring, and bottom also there is a circular ring because there is a thickness for the pipe, and there are two curved surface areas. One is CSA inner, inside curved surface area, and CSA outer, that is outside curved surface area. So radius of the inner cylinder is small r, radius of outer cylinder capital R. CSA inner, that is curved surface area of inner curved surface area, is equal to inner circumference into height, that is 2 pi small r into h. CSA outer is equal to outer circumference into height, that is 2 pi capital R into h. Circular ring area, here the top circular ring area and bottom circular ring area both are identical, and hence the area is same. So what is the circular area, ring area, is equal to outer circle area minus inner circle area gives you the circular ring. Therefore outer circular area is pi r square, capital R square, minus inner circle area is pi small r square. So pi times capital R square minus small r square. What is the total surface area of this cylinder? Total surface area refers to the entire area where we can paint it. So total surface area is CSA inner, CSA outer plus 2 times circular ring areas, because there are two circular rings which are identical, and hence 2 times I have to consider the area of the circular ring. So TSA is equal to CSA inner 2 pi small rh plus CSA outer 2 pi capital RH, and 2 times circular ring area 2 times pi r square minus small r square. this one, but 2 times. This is the total surface area. With regard to volume, there are two volumes here. One is the volume of the material and the other is the volume of the chocolate. Volume of the chocolate or the volume of the contents. The meaning is you close the bottom here and put some water, pour into this hollow pipe the water. So what is the volume that it can hold? That volume is referred to as the volume of the chocolate or the volume of the contents I refer to. It is see, chocolate, what I am saying is you will remember, you will be able to remember. So how to remember, you will be able to remember, that is one thing, but technically speaking, we call that as the volume of contents there. Okay, volume of material and volume of content. Volume of material is what basically, suppose if I give you a wood here, then what is the volume of the wood required to manufacture this thing? What you will do if I give you a wood for this, you will make an outer cylinder first and then you cut the inner cylinder and throw it off, isn't it? Therefore, the volume of the material is equal to outer volume minus inner volume. What is that? Outer cylindrical volume minus inner cylindrical volume, or the volume of the outer cylinder minus volume of the inner cylinder in simple terms. Volume of the outer cylinder is cross section area into height pi capital R square h minus volume of the inner cylinder is pi small r square into h. So take pi h common, r square, capital R square minus small r square. This is the volume of the material. You got it? And what is the volume of the contents? Basically the contents is equal to only the volume of the inner cylindrical part, and therefore it is pi r square h, pi small r square h, because for the inner cylinder small r is the radius. Okay, so these, based on this also we are going to solve some numericals, and of course with respect to the surface areas, next question out of 13's in exercise 13.2, the third question is related to the pipe section. So before that you must pause the video and make a note of all these things in detail. Okay, note down please. Question number 3. A metal pipe is 77 centimeter long. The inner diameter of cross section is 4 centimeter. The outer diameter being 4.4 centimeter. Find its inner curved surface area, outer curved surface area and total surface area. Very simple problem. See, inner diameter is given, so inner radius you can calculate. Outer diameter is given, outer radius you can calculate. What about the height? 77 centimeter long means it is height basically given to you. So all the information, small r, capital R as well as h is given to you, and these are by simply applying the formula you can calculate. So come, let's solve this on the board now. So question number 3, this is the pipe section, and the length of the pipe section is 77 centimeter. The length here we can consider it to be height there, isn't it? Now inner diameter is given as 4 centimeter, inner radius is small r 2 centimeter. Outer diameter is given as 4.4 centimeter, therefore outer radius is capital R equals 2.2. How did you get 2.2? 4.4 divided by 2. Now CSA inner is the question. Inner circumference into height, 2 pi small r into h, 2 into 22 by 7 into small r is 2 into height is 77. 7 ones are 7 11s are. So 2 into 22 into 2, this is 88 into 11, which you get 968 square centimeter. So inner curved surface area is 968 square centimeter. Now CSA outer 2 pi capital R into h, 2 into 22 by 7 into 2.2 into 77, you get 1064.8 square centimeter. Now how do you calculate the TSA here? TSA is Raghavendra, keep that, don't do anything and don't disturb. Now total surface area is curved surface area inner plus curved surface area outer plus 2 times ring area, because the top ring area plus bottom ring area both being identical, 2 times ring area. So CSA inner already we have calculated here from 1, CSA outer from 2 already calculated, and ring area is nothing but pi times r square minus r square, 2 times pi into bracket capital R square minus r square. So this works out to be 2032.8 plus 2 into 22 by 7 into 2.2 the whole square minus 2 square, this plus 44 by 7 into, see, a square minus b square I am considering as a plus b into a minus b. Is it right? A plus b into a minus b. So 2.2 plus 2, 2.2 minus 2. So if you work out, it is giving you TSA as 2038.08 square centimeter. Clear? Quite simple problem. It is basically all the formula we need to apply and find out the CSA inner, CSA outer, and also the total surface area. Okay. So see, for your information, it is not advisable to remember the simplified formula of the TSA. Never it will be helpful. How to remember that formula? Like this: CSA inner, CSA outer plus 2 times ring area. That way only you will be able to solve these numericals very easily. Otherwise, some students will byheart that one, and it is difficult to remember itself first of all. Whereas all these things, CSA inner, CSA outer, ring area, these are the basic elements of a particular cylinder, that is a right circular hollow cylinder, which you will be able to remember. Okay, so make a note of this sum. Question number 5. A cylindrical pillar is 50 cm in diameter and 3.5 meter in height. So cylindrical pillar diameter is given and height is given to you. But only thing is, here it is centimeter, here it is in meter. Make sure you maintain the homogeneity of units. Find the cost of painting the curved surface area of the pillar at the rate of rupees 12.5 per square meter. As the rate is given in square meter, per square meter, I will convert even this centimeter, that is the diameter in terms of meter, and take it for the calculation. That is more important. Okay, by reading the question you should be able to understand what units of measurement should be maintained, whether centimeter or meter, etc. Okay, so I will here convert 50 centimeter to meter and then calculate the curved surface area and multiply the curved surface area by the rate to get the total cost of painting. Simple sum. Let us solve now. Here question number 5. It is a pillar here. Okay, this is a cylindrical pillar, and radius is given to you, height is also given to you. So given information, diameter is 50 centimeter, radius is 50 by 2, which is 25 centimeter. As I said, in order to maintain the homogeneity, I am converting it into meters. So 25 by 100 gives you 0.25 meter. Is it clear? Next, height is 3.5 meter. What is the total cost? Total cost is total cost of painting. See, pillar, you cannot paint the top and bottom portion because it is a pillar. On the top some beams will be there, and bottom it is rested on the ground basically. Not only that, in the question itself he has asked, see here in the question itself, find the cost of painting the curved surface area of the pillar. You should be very careful in such questions. So what is the cost of painting? Only the curved surface area, and therefore the total cost of painting is equal to curved surface area into rate. Rate is given as 12.5 rupees per square meter. So what is the formula for curved surface area? 2 pi RH into rupees 12.5 per square meter. 2 into 22 by 7 into radius is 0.25 meter into 3.5 meter height into 12 rupees 50 by 6, that is 12.5. So 7 ones are 7, 0.5s are 3.5. So here little bit modification, 2 into 2, 44 into 25, 0.25 is nothing but 1 by 4 and 0.5 is nothing but 1 by 2 into 12.5 as it is. So 4 ones are 4 11s are. So 11 divided by 2 gives you 5.5, and here it is 12.5. 5.5 into 12.5 gives you rupees 68.75. So the total cost of painting the curved surface area at the rate of rupees 12.5 per square meter is rupees 68.75. Okay, make a note of this. Question number 7. Inner diameter of circular well is 3.5 meter and its depth is 10 meter. Find its inner curved surface area. The cost of plastering this curved surface area at the rate of rupees 40 per square centimeter. It is similar to the previous question. We'll solve this. Very simple one. Question number 7. This is a well here. Inner diameter is given as 3.5 meter. So you can calculate the radius as 3.5 by 2 meter. Depth of the well is 10 meter. So inner curved surface area is what we have to find out, which is circumference into height 2 pi r into h. 2 into 22 by 7 into radius is 3.5 by 2 into height is 10 meters. So 7 ones are 7.5s are. Then what we did here, 22 into 2 22 into 2 into 0.5 into 5. If you calculate, you get 110 square meter. So the inner curved surface area is 110 square meters. Now cost of plastering. Cost of plastering is equal to the inner curved surface area into rate. So inner curved surface area is 110 into rate is rupees 40 per square meter. So which gives you 11 fours are 44, 4,400 rupees for the cost of plastering the inner surface area. See, here we are not taking the base area, okay, that is important. Only the plastering will be done on the four sides of a well, isn't it? And therefore the curved surface area is considered for the cost of plastering of the inside well. Okay, so make a note of this one. Question number 9. Find the lateral or curved surface area of a closed cylindrical petrol storage tank that is 4.2 meter in diameter and 4.5 meter height. Simple. The radius and height is given to you, and you have to find out the curved surface area. Circumference into height 2 pi r h is the formula. How much steel was actually used? If 1/12 of the steel actually used was wasted in making the tank. So let us solve this on the board. Question number 9. There is a petrol storage tank which is cylindrical in shape. Diameter is 4.2 meter and height is 4.5 meter. So curved surface area of the petrol storage tank is the question asked. So diameter is 4.2, therefore radius is 2.1 meter and height is 4.5 meter. Curved surface area of the petrol tank is equal to circumference into height 2 pi r into h. If you substitute the values, you get 59.4 square meters. So 59.4 square meters is basically only the curved surface area. Remember, it is only the curved surface area. Okay. See, the second part of the question asked is very interesting. How much steel actually is used is the question. How much steel is used in building this one? He gives some wastage also. So how much steel actually used is, I have to calculate first area, what is that is required, what is the steel required. The steel required for this is basically used, actually steel used, actual steel usage and the steel used for fabrication of this tank is different. Why it is so? Actual steel could be much more. Why? Because wastage can go from that. Cutting wastage will be there, some corners will be taken out which cannot be completely utilized. For example, if you are given a rectangular shape and when you cut circular parts, say for example top and bottom circular parts, then the corner portions are wasted or not. So our actual steel usage is more than the calculated steel usage. So first let us calculate how much steel is utilized here. The calculation of utilization of the steel by formula is the total surface area of the tank. Total surface area is equal to curved surface area plus 2 times the base areas, top base area plus bottom base area, which is 2 times pi r square. CSA already have worked out 59.4 and 59.4 plus 2 times pi r square. If you work out, it is giving you 87.12 square meters. It is 87.12 square meters. Now this is calculated, but actually used much more than that. Why it is more than that? Some wastage is there. So let me assume, let x square meters be the actual steel utilized. So let x square meter be the quantity of the steel actually used. What is the wastage? 1/12 of the actual steel used is a wastage. Therefore, if x is the actually used, wastage is 1/12 of x square meters. So the difference of this one, that means actual steel is there, cut that wastage, take it out. The remaining steel should be equal to the calculated TSA, and therefore x minus wastage or actual used minus wastage gives you the calculated TSA, which is 87.12 square meter. समझ में आ रहा है आपको? and therefore x minus 1/12 of x is equal to 87.12. LCM take it, 12x minus x by 12 equals 87.12. So 12x minus x is 11x. 11x is equal to 12 into 87.12, and therefore x is equal to 87.12 into 12 divided by 11. That gives you 95.04 square meters, and hence the actual steel utilized is 95.04 square meters. So even though, for example, if you are a manufacturer, the steel quantity that is purchased is the actual steel quantity, that is 95.04 square meters, isn't it? But used over here by calculation 87.12. What happened to the difference? 95.04 minus this 87.12, that is the wastage. That is how this problem is. Mark this problem, okay? And you must understand very clearly this one. Watch this couple of times, whatever that I have explained, mark it a critical sum and then solve yourself, okay? So make a note of this. Question number 11. Question number 11 is also a simple one. My suggestion would be you solve all the rest of the numericals, because if I solve all those, then you will be lacking practice. आप लोगों को तो solve करना ही है ना. If any difficulty, you can discuss with me during live sessions also. But make sure that you solve all these numericals yourself, and for which you need to know the tables also, which is very important. Like 12, 13, 14, 16, 17, 18, 19. These are the tables which you have to by heart. Otherwise, you'll be taking a lot of time for such numericals. Okay. So with this, I would like to end the lecture over here. In my next class, I'll be taking the volumes with respect to the cylinders. Thank you very much for watching, and see you soon.